Hi, in this video, I will be talking about radians, which is another way for us to measure angles. Okay, so all this time that we have learned about angle measurements, we're always talking about degrees. However, degrees are somewhat arbitrary. So today, if let's say I have a circle, okay, let me do that better. If I have a circle, and if I ask you what is the angle of a circle, you will say 360 degrees. Okay, but angles measured in degrees, they are arbitrary, which means they are not really the best way, the most ideal way to measure angles, because we can always find a more accurate way to measure them. So instead of measuring them, we're actually going to describe angles using radians, which is the simple definition would be it is simply the ratio of your arc length to your radius. Okay, so let me erase the 360. Okay, so radians, the very simple definition of radian is arc length over radius. It is just a ratio, right? So, arc length, I'll show you what's an arc. So here I have a circle, and that will be my center. My center is here, so that will be my radius. Right, my radius is there. Let's say today, if I move along the circumference for, let me change it back, sorry. If I move along the circumference, right, and I'm going to travel a distance of r, okay, a distance of r. Now, the angle that I make here, that would be, so let's see what's the angle for that in terms of radian, right? So let's say in this case, my arc, if I kind of create a zoomed in version of what I just drew there, this is going to be r. Let me do a better job with the drawing. So I have r here. I'm going to travel that much, and this is r, and my angle is theta here, right? So in that case, my theta, in terms of radian, would be 1r over r, which is 1. So the angle here is 1 radian. Okay. Now if I say, instead of going that much, I'm actually going to go a bit more. Let's say even more. So I'm going to go 2r. Right, so r here, r there. Now I have this sector. This is 2r, right? R plus r, I have 2r, and my radius is stayed the same. So my angle is going to be here. So my theta is going to be, my arc length is 2r. My arc length is 2r over my radius is r. So my angle in terms of radian is 2 radians, right? 2 radian. Okay. Now let's continue. If I walk another r, then I have all the way here, right? So if I draw that one, I would have something like this, right? Something like that. And where my arc length, which is this part, my arc length is now 3r, and my radius is r. So my angle here, theta, my theta is going to be 3r over r, which is 3. So my angle is equal to 3 radian. Okay, and we can do that again. This is r, and as you can imagine, this angle here, that's going to be 4 radian, right? that would be 4 radian. If I do another one, that would be another r. So another r. So that the angle all the way there, this angle is going to be 5 radian. Right? This is going to be 5 radian. Okay, 5 radian. And I'm going to go another r. So that would be the angle all the way there. It's going to be this angle, this whole angle here is going to be 6r over r, which means 6 radian. Now I have this extra bit left, right? I have this extra bit left. Now let me ask you, if I covered the whole thing, if I covered the full circle, if I covered the full circle, how much distance have I covered? So I start from here. This is my center, and I'm gonna walk. Just keep on walking, and then I'm back to where I started. How much distance have I covered? I have covered the circumference, right? So that's my circumference. And if I want to find, and this is I no longer have an arc. In fact, I have the entire circumference, and I'm going to replace the circumference, right? I'm going to replace the circumference with the arc length. So circumference is equal to 2 pi r. We learned that back in middle school. Circumference is equal to 2 pi r. So my angle, this is my angle here. That's my theta now. My theta makes the whole a complete circle. My angle in radian is now equal to the distance traveled, which is 2 pi r, the arc length, but in this case, we don't have an arc anymore. We have a circumference over the r. The r and the r cancels out. I have 2 pi. So what's the angle that we have here? The angle that we have, this angle that we have is 2 pi radian. Okay, so in other words, if I try to make the connection between radian and degree, we said that in degree, one full circle is 360 degrees. In terms of radian, one full circle is 2 pi radian. Right? So if I have, say, 1 pi radian, that would be 180 degrees, because I just divide this by half, right? Or multiply by half. If I have, say, 60 degrees, how much radian is that? So from 180 to 60, I just multiply by 60 over 180, right? Because 180 times 180, they cancel out. The denominator and the 180 in the denominator will cancel out with the 180, give us 60 left. And this is equal to 1 over 3. So I'm going to multiply this by 1 over 3, and that gives us pi over 3 radian. Okay, let's do another one. Let's say today if I have 120 degrees, so from 180 to 120, I need to multiply by, again, with the denominator 180, and then I'll have 120 at the top. So I'm going to multiply pi by the same thing. So I will have pi 120 over 180 pi. The 0 and the 0 cuts out, divided by 6, I have 2 over 3. So this is 2 over 3 pi. Okay. If I have, say, let's do one more. Let's say if I have, let's try to convert pi to degrees. Let's say if I have, say, 5 pi over 6 radian, and I want to convert that to degree, what do? So I can refer back to what I have here. Right. So if 1 pi is equal to 580, then 5 pi over 6, all I have to do is to multiply 180 by 5 pi over 6. So 180 multiplied by 5 pi over 6, I would have 150. Okay. I don't recommend you guys to remember. In the textbook, you can find that they give you guys like almost like an equation that you need to remember. So 1 pi is equal to 180. What do you do if you multiply? What do you do if you convert radians to degrees or degrees to radian? In the textbook, they kind of give you a very prescribed instruction on doing that. I do not recommend you guys to do that. In fact, what you really should remember is these two lines here, right? 360 is equal to 2 pi, hence pi is equal to 180. If you remember that, and with a little bit of math, it's actually better that way, okay, to find your conversions manually. Okay, I hope you guys find this video helpful. In the next video, I'll be talking about arc length and area of sectors. All right, I'll see you guys. Bye.